There you go. All right, let's give people one more minute and then we will dive in
Cool. And I will join
here.
the other.
Yeah, I'm not sure. I don't know. We will use service-driven design, maybe. I feel like that's like more our style.
What are you referring to?
Oh, Adrian was saying, will you use DDD for the crawler today?
I was making fun of it somewhere, wasn't I?
You were. All right, let me share my screen here.
Define DDD. Well,
that's fair. That's fair.
Time to start aggregating things. Okay,
all
joining
right.
me.
Let's see. Maybe that's too big. Is this size okay for everyone?
Well, yeah, I'll defer to them. I'm joining the link.
Yeah. Let's see. Okay. All right. Sounds like this is good. So I guess introduction for today, where we thought we'd take a break from the Akka to ZIO series. It's obviously great and it's timely, and particularly if you're having that problem of you're on Akka, then it's very relevant to you, and we're definitely going to come back and have more content on that. But we've also got plenty of people here who are just doing stuff with ZIO and are very happy doing stuff with ZIO, and for them it's probably interesting, and maybe there'll be some good stuff that comes out of they use, but they're just kind of doing their stuff with ZIO, and so we want to make sure that we've got stuff for that too. And I think something that we've wanted to do for a little while is just have a little session on building a web crawler together, just because it seems like one of those kind of fun, tangible things that you'd like to be able to do. And it's great to learn about like all the theory and all the low level stuff, but sometimes we can get kind of so much in that like I feel like sometimes with Scala we don't get past that to like doing the cool things. So I think this is like a nice, pretty easy one where we get to do some of the cool things. If you have read Zymposium, there's a chapter towards the end where we do a version of this. I think we're going to try to do like a little bit of a simpler version right now, well, at least simplify the kind of core implementation, though I think Kit also has some ideas of how to make it fancier. So yeah, I think we'll have some fun today. And as always, feel free to jump in with questions here. I think, as usual, we'd like to do most of our stuff, but it's fun to live code together. But I've just done a little bit of, I would say, the boring stuff for us here. So the only thing we're starting with is we've got this URL data type, which is just like a slightly nicer wrapper for a java.net URL. And it's just got some kind of sane methods of like equals, hash code. We can convert it to a string. We can make one from a string, and it'll give us an option and do a little bit of validation for us. But not really exciting at all, just so I'm not kind of fumbling around with the java.net URL API as we're doing stuff here. And then the only other thing I'm starting us with is this extract URLs method, which takes a root and some HTML, and is basically going to go through and is going to just find all of the URLs in there. So again, like nothing magical here. It's using like a regex and catches exceptions, but just was a little bit kind of low level and not the stuff I thought would be fun for us to be doing together. Kid is so disappointed. He loves his regexes.
Regex day. Yeah, we got to do some regex.
I think you do have a soft spot for the regexes. Yeah. So let's kind of start thinking about how we want to do this. And I think we can follow a little bit of like, we can call it service-based design, I guess. But so I think the first thing I'm going to think about is like, okay, what do I want this like web crawler thing to be? And I'm going to try to follow the like ZIO2 pattern of essentially everything is going to be a service. So even essentially, we're going to have as minimal of a main method as possible. Like basically, all of our logic is going to be in this web crawler thing. And then all our main method is going to do is basically access one of these and start it up. And so as a starting point, I think I'm just going to give this web crawler a run method. And like usual, we're going to say we don't want our methods on our interfaces to have any environmental requirements, because we're going to build that into the layers that this depends on. And in this case, I think we're going to say this one can't fail, and it's not going to return a useful value for now. We'll see when we construct this, we'll kind of give it a function that describes what we want to do with the different things we're getting from the crawl, and we'll kind of control it that way. And some of these things, it's not like there's a right or a wrong way. We're just walking through one way. And I think even if you kind of look for ZIO web crawler, I think even relatively recently people have been doing their own versions of it. So you can look at those and you can see different approaches and decide what you would like to do here. So we're going to have this web crawler interface. And so if I kind of start at like a very high level, so my typical pattern might be I would start with some Z layer that is going to create one of these things. And I might start with some live implementation of that. So I could do web crawler live, and I'll start with this just being empty. And this will extend web crawler. And we'll have an implementation of this thing, which right now is not going to be anything. And what we'll eventually end up doing here is we'll kind of put more things in here that are the things that this depends on.
One just to mention real quick, like one thing I like about this, and you're sort of already following this pattern, is like even if we didn't like know what our target state was, even if we didn't rehearse this or know like the back of our hand how a web crawler should be. Say we came to this from a place of pure ignorance. We wanted to explore what it was going to be like to write a web crawler from scratch, which is kind of what we're trying to simulate. This is exactly how I think I would write it. I'm not sure about you, but like one of the beautiful things about this pattern is we can just start implementing it. And then as we realize we need things, as we go and sort of like reach out, it's like, oh, I need this data type. I need this function. I need this capability. We can add them to our, parameter list. We can have other services if it's more of a service thing we need, or if it's another parameter we need, we'll add it to our list of. We'll turn this into a def and add it to our list of parameters. I don't know. I just think this is like a really good way of writing code and something that I think Scala is really good at, letting you just sort of start from what you want, start from the end, and just sort of like manifest magically things as you reach out for them, as you find yourself stumbling towards them.
Yeah, and I think the triple question mark is lovely in that regard. Yeah. And so I think another thing we can do in the same vein is, even as we start to sketch this out, we can actually kind of create like how it would be when we actually called it, and we can kind of see how that looks and feels here. So here I'm going to create this object main, and I'll extend ZIO app default here. And so now I can imagine that maybe I'm going to say web crawler is going to be web crawler.live. And then this ZIO app default is expecting a run method. And so here I could do something. Let me initially I'll do service with ZIO web crawler.run. And so if I compile this, this is going to give me this compilation error that it needs a web crawler. So I could just do .provide web crawler.
Nice.
And already I've got kind of a program that's compiling here. And I think there are a couple things we may want to figure out here. Like, do we just want to call this, or do we want to like call it and maybe fork it and interrupt it at some point? Because this crawl, depending on how we do it, is maybe going to kind of like crawl forever if we just leave it and like crawl over the whole web. and we might want to be able to kind of shut it down at some point. And if we think that's nice, maybe that kind of starts to inform our design here. And maybe we say, well, this has actually become something more like, we're going to take this thing and we're going to fork this into a fiber. And then maybe we're going to get some console input, and we're going to, maybe sounds reasonable. And then we're going to interrupt the fiber, and we're going to be done here. So now this is kind of starting to imply that this run method is a little bit more like when we start like a server in ZIO, that this is kind of going to start some process that's just going to go on, at least when we fork it here. And then it's, how long as it's going on, it's just going to be crawling things and doing something with those things it crawls. And then when we've kind of seen enough to at least satisfy ourselves for our little Zymposium session that it's crawling lots of things and crawling efficiently and maybe visualizing something with it, then we'll just hit enter and we'll kind of shut the thing down cleanly, and that'll be nice. So again, not necessarily the way we have to do it, but I think this is a nice example of that iterative process of we can like start to sketch some of that out and like see how it feels, and we can always change it later, but this is already starting to kind of inform what we're doing, and we're getting a little bit better an idea of what the web crawler is going to be doing here. Just one minor thing we might want to do here, when we see this service with ZIO pattern, if we want to, we can always factor that out into one of those accessor methods. It may not be necessary here because we're only really calling in this one place, but maybe just to illustrate that pattern, I could do run here. And this is going to be a ZIO that requires a web crawler, nothing unit. And it's just going to be that same service with ZIO run. And then when I go back to this, now this can just be web crawler.run, which maybe feels a little bit more organic depending on how we feel about it.
And then hopefully in Scala 3 soon, we'll get accessors or annotation macros so we can generate those as well in Scala 3, and then yeah, it'll be compatible in both versions. A quick question: I see you put the provide here. I think it pretty much doesn't matter in this case, but could we have also put it at the end of this program?
Yeah, we definitely could have. I think I have a slight aesthetic thing of like, I don't like the like extra layer of braces, but I mean, we could also just easily make this like val program, and we could pull the provide here, and then we could do that. So yeah, those are kind of, that's my little bugaboo.
No, the extra braces are awkward, and so yeah, I think that's kind of what I do sometimes. Just program there and then just call provide here.
Yeah.
All right, cool.
Great. So now I think this is also like just like starting to think about like, okay, this is kind of the user experience using this. I think one thing that like is becoming a little bit apparent here is there's kind of not enough information here probably to do this based on what we have of like right now this web crawler is just kind of crawling the web in the complete abstract, and that's it's not really even clear what that means. And I think a lot of times like the way we actually crawl is we start with some initial place or relatively small set of places we're crawling from, and we kind of look at those pages and we kind of get all the links from them, and then we spider out, right? That's kind of another word for this. And we like look at all those pages and we get all their links and we go from there. So we're kind of expanding outward here. And so one thing that I think that implies, maybe that it may imply a couple things, but I think maybe the first thing it implies is that we need to have some way of getting these initial ones that we're going to start with. And maybe we would call that the seeds that we're going to start with. So we can kind of take that idea and we can feed it back into this and then into our main method and kind of see how that feels. But I think maybe what that's meaning is that this isn't actually this val live, but it's maybe something more like def make. And maybe the first thing is it's got these seeds, and maybe these are a set of this URL type that we have here. And so if we have that, then we're going to have to go here. And so this is now going to be something like webcrawler.make. And then here, this is going to be a set. And I think we've got like a URL dot, let's see what our actual method on URLs. I think it's from, so it's URL.make.
That's the making.
So let's make, and then let's pick someone. I think the one I was using before that I kind of like, I like the New York Times. So I'm going to do that. And then I think we're going to kind of live a little bit wild, and we're going to say this is indeed a valid URL, and just so we're just going to call get here to get it out of the option from this. And so I think this is starting to feel like a little bit better of like, okay, now like, yes, we're saying we want to start from this page.
One quick question. So I think maybe, I think similar to what I was just saying before, where these designs are kind of interchangeable, but another option, I guess, would have been putting the seeds here. Is there a reason why you go with putting them as part of the layer? I mean, and sometimes you can decide, some would be in the method, some would involve the layer creation. What would be the thought to do one versus the other?
Yeah, I think in this case, we could kind of do both of them. I think my idea was kind of that the web crawler is this like stateful thing that we're like creating, and that potentially has some of its own internal state, and that when we create it, we kind of say everything we want to do. But I think you're right. We could also push it into the run method, and that would be completely fine. And so, I mean, I'm happy either way. I think if you want to move it there, I think we could do that as well.
Yeah, I think for this, it kind of makes sense, because then you might want to run multiple times instead of having to provide a new layer. Obviously, they've been kind of forever, but yeah.
Yeah, so let's show that back to being live. Let's make this take the seeds, this set of URL here, and then this is also going to oops become run with these seeds. Set of URL, and we pass the seeds. We'll get the compiler to help us here.
Cool. Nice.
And then I think we're still, let's see. Oh, I think we just didn't save. Let's see.
Oh yeah, I put it down at the bottom now, actually.
Oh, and then now here. So maybe let's still like copy this as a value. So maybe let's do like seeds is equal to, and we had that set of URL.make. All right, so that seems nice. So kind of continuing with that idea of like starting to get into the logic of this and what we're going to do here. So we're going to start with these initial seeds, and then we're basically going to take each of them and we're going to like scrape all of the links from them. And then I think we're going to have a little bit of a choice there of essentially which of those links we're going to crawl to. So, I mean, one option, obviously, maybe the simplest one is like crawl to everything, take over the whole world. But we could have some cases where like maybe we just want to kind of get the list of like every New York Times page, and we don't want to like start going to like other magazines or newspapers or whatever and kind of get distracted with them. So it might be nice to be able to specify that. And so I think if we're kind of following our pattern here, we could say that's maybe another method on this run method. And so maybe we call that something like should crawl. And at least a simple way to conceptualize this is it's just a function from one of these URLs to a Boolean. So basically we'll get all these links and we'll decide which ones we want to crawl to, and the ones that we don't, we'll throw away. And maybe if we go back to here, maybe our initial one is just going to be, yeah, we're just going to crawl the world here. And then, let's see, I think we got some, what we got here. Oh, I think we're missing, oh, this needs to be a URL.
Oh, yep.
No. Let's see, we're saving. We're still, oh, and I think, let's see, I think we're just off. Yeah, this is all. So we'll make it with the seeds. We'll make it with whether we should crawl. And then I think at least the way we've set this up here, as we've got it set up now, I think this is going to be helpful for actually doing the crawl, but it's not going to be very interesting for us because we're kind of not doing anything with the results of this. And if we go back to the signature we've created so far of this run method, it's not giving us back a value itself. So that kind of means that we've got to give it what we want to do with these values. And so maybe we can give it one more parameter that maybe we call like process result. And this could maybe give us a URL and maybe a string, which would be like the body, like HTML we're going to get from this. And it's just going to give us back UIO of any here. That's just going to be what we want to do with this. So we could print it out, or we could put it into some other ref that's going to contain it and do some further processing on it, or we could write it to a file, or we could kind of do whatever we wanted with it. And so if we do that, we'll kind of do a little bit more of just, we'll like push this through everywhere. So maybe my initial process result. So this is just going to be a function from URL string. It's not going to be unit because that would be super boring. But it will be something like maybe we'll take just the URL initially. I think this is where I think Kit has some more exciting ideas for us down the road. But right now we'll just print out the URL and we'll die on that.
We need to string that?
Yeah, or I think it may have a URL method. I think it's like a URL dot. Or URL dot parsed. Yeah, I think or it does have a string. We may just need to try this once and see what it looks like, and we can always change it. Okay, and then we're going to need to pass that into here.
Cool.
Okay, so now I think this is feeling relatively good from like a user perspective. Now we've obviously got to go and implement this thing. And I think, again, that's like this idea of this nice like service-driven design of like, we've already fleshed out a lot of like the thinking of like the API and the interface, and even that's pushed us to think about how this would work. And we actually haven't really implemented anything yet, though if we wanted to, we could have also proceeded a little bit the opposite way, and we could have started with implementing some of this and kind of seen what we needed here. And we may actually do that in a second. Okay, so now we're ready to, I think, start implementing this. And so if we maybe just in a little bit of text here, kind of sketch out what we're talking about. So I think we want to basically take the initial seeds and grab those web pages. We want to extract all the links from the web pages. And then we want to basically repeat with all of those. And then we're going to have some stuff we got to like take care of we'll probably need some kind of state to keep track of where we visited, because we don't want to, we can imagine like a lot of times pages link back and forth to each other. So we don't want to just bounce back and forth to the same page. We kind of, once we've crawled it once, we want to just put it aside and not bother crawling it again. And I think another concern we're going to have, just maybe just getting things on the table, is we're going to want this to be, I guess you could call it either scalable, or maybe another way to say it would be long running. But we have this idea of, we're going to go farther and farther and farther out here in our crawling. And at least as we get to a little bit more of a full implementation here, we'd like this to operate in a way where, other than the fact that we're maybe building this larger data structure, kind of keeping track of things we visited, we're not really incurring any overhead for doing that. And so we can kind of keep crawling and crawling and crawling, and we don't like slow down like halfway through as we're like got more stuff here. So that's something we're going to want to think about a little bit.
Cool.
And so I think this first one of like, take the initial seeds and grab those web pages is probably a good example of where now thinking about implementing may kind of push us on the architecture here, because it seems pretty clear here we're going to need to like actually like interact with the web, right? We're going to actually need to like load this URL. And it feels like that's a lower level of logic of what we're doing here. And so that's a good clue for us that that means we just want to push it into another service. And so maybe we'll create another service, and maybe I'll call it the web service. And so I'll import ZIO, and I'll just start by defining some trait web. Won't even say what it is yet. And then if we go back to the web crawler live here, we can just immediately say, okay, this is going to require a web service. And let's see, are we web? Oh, I just need to save this. Okay. So now let's think about what the web service interface is going to be. So it seems like the web service should basically take some URL that we're interested in and should give us the content of that URL. And so again, we can kind of just like start to sketch this out even without like having it yet. So we can say, okay, we're going to have some final case class web live that's going to extend this web interface. And so it's going to have some way of actually doing this thing, which we'll have to figure out shortly, because we're probably getting to the end of our architecture and to the beginning of where we actually need to do stuff. And I don't think we're going to use ZIO from Future there. Thank you, though, Copilot. And then we can have some live layer. That's going to be a Z layer, any nothing web for now. And so initially we could just say that's going to succeed with this web live thingy. And now if we've got that, we can also start to flesh this out a little bit more. And so here we could say, okay, well, if this needs the web service, then we could just use Z layer dot from function web crawler live here. Yeah. And then that's going to require us to update this signature and say this requires a web service. And then that's going to require us for this to compile for, well, maybe let me get his, yeah, let's see, we can see Kit's nice error messages. So now we got this error message that we're missing the web service for this. And so we can do that by just providing it, the web service. And I think we probably, called it web.live. And there we go. So, okay, so now again, we can kind of look at this at these different levels, and we can see here, okay, this still, I think, feels pretty nice of we're just providing the web crawler and then we're providing this web service. And we can imagine how this could make things testable of we might want to test our crawling logic independently of like actually crawling the web, because for actually crawling the web, it's going to be super hard to test because like the web's changing every second of every minute. But here we could create some web service that kind of has a fixed like set of web pages, and we could make sure that we like crawl the things that we wanted to if we wanted. Mm-hmm. And now we've also got a little bit of a choice here. We can either, if we want to, we can just defer the whole web service, and we could basically implement this whole thing and just assume that we can eventually implement this get URL method. Or we can go the other way around, and we can kind of say, well, let's like, I mean, this get URL method is probably like a little bit ugly, but like fine and probably conceptually simpler. Maybe we should just knock this out, and then we can go back to the web crawler and we can kind of focus on that.
Or and we could, right? We're two workers on a team. And,
yeah, exactly.
Let's open
so
up.
Yeah,
let's open up Jira.
we'll create, yeah, we should not start working on it yet. We definitely need to create some tickets before we do anything. So we'll do that for the rest of the symposium, and maybe next symposium we will work on those tickets.
If everyone could think of a number, but don't post it. Don't put the number in the chat, not yet.
Yes,
Anyway.
we need to point it.
I've been started.
But I think I'm going to suggest that we do this web interface first, just because I think it'll be relatively simple and it'll kind of get it out of the way, and then we'll kind of have a crescendo of our little symposium here of kind of getting to the higher level stuff.
Could I,
but yeah,
one point. So yeah, so we made these layers first, which is totally fine. I found, especially during the process of iterating like this, to just sort of save the re-editing, you know, the type signature and whatnot. So we could do this zlayer.succeed, but I kind of just like starting with from function and then doing .apply to begin with, because then it'll work with nullery services. Now we won't ever have to change that. And likewise, I actually lately haven't been annotating these things.
You're a wild man.
Not at the beginning. Maybe once we during this process of iteration, sure, maybe you have a CI linting warning or fatal error. We can, as we're editing, these will all be inferred to the top of the application. So we'll still get that warning from the top of the app. And then we can just, you know, use ideally like, you know, whatever, option enter or some kind of like fill in that type later, and then we can tweak it if we want to. I don't know. I've just found that, like, you know, I'm always all about feedback loops and little tricks, but I found that to be nice. If you want to go max speed, get reckless.
All right, well, let's try to implement this, and we'll see if we need other services, and then if we don't, maybe we can just fill this in and simplify it, but we can kind of defer that for a bit here. So this thing here, I think I'm going to try to do this in like the dumbest way possible initially and kind of start from there. So I'm going to use ZIO succeed initially just to kind of wrap something here. And then I think there's this scala.io.source from URL. I think that seems non-crazy. We'll see if that kind of blows up in our face, but that seems non-crazy. And then I think the only other change I'm going to do here is I think clearly this is doing all sorts of like network stuff. So this can throw exceptions. And then this is also going to be a blocking call in all likelihood. Maybe eventually I could use fancier things that would be non-blocking, but right now this is blocking. And, you know, yes, I've got auto blocking and everything. But if I know it is, let me just kind of call a spade, and let me use this attempt blocking IO constructor. And I think this will basically give me what I need. I mean, maybe modulo, like, I don't know if I should have called toString or not, but I think this is pretty good. And so this wouldn't take, we're not going to need any other services here. And so if we feel good about that, then we can kind of, well, okay, if my VS Code was being more helpful, we can fill in the type signature, or we can just do it ourselves here. But yeah, I think that's kind of a really good thought of like how we can defer that if we're still figuring it out. So, okay, so now then we are ready to do the actual implementation here. And we're kind of, I guess we're at the point where we've done everything else. We've like architected everything. We've done all the smaller things. We like actually need to do the like real thing.
We got a question.
Yeah.
Which is, does this long-running fiber qualify for the auto-blocking detection thingy? So the crawler itself, would this qualify as it's this long-running process to be?
So in all likelihood, not. We're going to see it may depend on what we're doing here, but I don't think so, because the auto-blocking detection is based on when we have a fiber that's not doing another ZIO operation. So think about every time there's an operation of ZIO runtime, every time there's a flat map, every time we change some state, anytime we do one of those ZIO operations, that is kind of the clue that we're not blocking. So the only time the auto blocking is kind of going to say we're blocking is if we're like running and we're running the same giant ZIO operation for a very long time. And in this case, I don't think that's going to be the case. We'll check for once we kind of get through this, but I think other than this one thing, which I mean, this may take a little bit of time, and I mean, here we're explicitly designating this as blocking. I think all the other things we're going to do are either just going to be quickly doing kind of those ZIO control flow operations of like flat mapping from one thing to another, or we're going to be suspending. And when we're suspending, that doesn't kind of count towards us potential blocking because we're not even in a running state.
So if this was our implementation, maybe that would then be blocking.
Exactly, because we're not returning control to the ZIO runtime for this like whole time. And so I mean, probably it would also be right to call it blocking there. But we're not going to do that. So I think the other thing that we're going to want to think about now is we're going to think a little bit about this idea of this being like scalable for long running computations, because we could probably do a pretty simple naive implementation where you can imagine maybe we just do like for each, or we just do for each par. And right, we could say like, hey, for each of these seeds, get the URL, and then if you should kind of take those results and filter them for the ones you should crawl, process the results, and then just call run again with that new set of URLs. And so we kind of have one top level run, and then we have a bunch of runs below that, and 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 so on. And so that's definitely like one, and I mean, it's probably a very, very simple approach we could take, but the problem there is we are kind of leaving a little bit behind as we go. So if we think about like normal code that's not with effects, right, we like to make things tail recursive, which essentially means that like once we go on to doing the next thing, there's nothing we're leaving behind is like, oh, there's this next step when we're done. We're just immediately able to go on to the next thing. And similarly here, I think we'd like to be able to do this in a way where we just go on to the next thing and we're not kind of keeping extra fibers around or anything like that. And so I think this is going to be a nice opportunity for us to explore using a pattern with a queue for this. And so I think the way we can maybe think about this is we'll have a queue that represents work that needs to be done. I think we'll kind of take care of that idea of not visiting the same things again by maybe having a ref that represents what we have already visited. And then I think we can basically just, we'll create a fixed number of fibers that each pull a value from a queue, process, and do that forever. So let's maybe explore that and see what that might look like.
Also, I like your approach, Adam. I think we are different in that way, where I feel like my approach is more akin to finger painting, where I just need to start just banging code around. And, yeah, and I feel like maybe I'm a little weaker at being able to just visualize and plan the whole thing. But it seems to be your approach, and it works very well for you.
Well. I feel like we complement each other very well, and your approach definitely works very well for you.
High fives. Yeah.
Okay, so I'm going to start off by creating this for comprehension here. And so I've got these two things that I need. A lot of times the first thing I want to do is I just want to like make my data structures. So I'm going to want this queue. And I think that's probably right that it's going to be an unbounded queue, and it is going to be a queue of URLs because this is kind of going to represent the work that needs to be done. And so each URL that goes into the queue is a new page that needs to be crawled. And then I'm going to want to create this ref. And it's going to need to have something inside it. I can initially use the question mark, but I got to figure out what that is. And so I think basically, at least in the simplest example, it's basically going to be just like a list of these URLs that we've visited. I think Kit may have some ideas for making this fancier, though I think we could also probably do it through this process result thing. But yeah, let's start with kind of the simple one. And I think just because maybe I want to kind of keep this simple and high level, maybe I'll make a little helper for ourselves.
Oh, I'm up here just a little bit. I'm not sure if this is what you had in mind.
Oh, you
crawl state. I'm on line 26 of this file.
Yeah, that looks great. Yeah, I just created a new file for it. So yeah, maybe we grab that and throw it in there.
Oh, that's my finger painting versus your.
No.
Boom. All right. Oops. And I started the discussion. What have I done? What have I go?
I don't know what the discussion thing does. That's funny. Huh. Can I like, no, I don't want to discuss this. There will be no discussion about the crawl state.
Oh.
So the crawl state maybe maintains like a set of URLs that we visited. And then the empty one can just be crawl state set.empty, and this is immutable, so this can just be a val. And then I could, maybe one of the nice things about this is I could like give myself some helper methods here if I wanted to. So maybe I could have something that's like visit, that's a URL and crawl state. I'm not sure I'm going to need to have visit, but we'll see. And maybe I could add something like visit all that's going to take a iterable of these URLs and is going to add them all to the crawl state. And that way I can just, I mean, here these are pretty simple, so it's debatable whether I really needed this, but you know, it can kind of keep things maybe a little bit nice and just organized here.
Absolutely.
So now if I go back to the web crawler, I can now make this ref with crawl state dot empty. And so now I've got my, we go back to kind of our ideas here. I've got my ref, I've got my queue. So now I want to create a fixed number of fibers that each pull from this queue and process it. And so here's another case where I think it's nice, it can be nice to kind of separate out this a little bit. And so maybe what I can do down here is I can make some new def that I'll call a worker. And this is going to describe the logic for what this worker is going to do. And again, I can kind of play with going back and forth between where I want to flesh things out and where I want to leave them ambiguous. So clearly I'm going to have to implement this worker at some point. But even if I've got this, and maybe right now I'll just not do the parentheses just because that kind of indicates it's side effecting. I could already start to kind of sketch out how I would do this. And so I could maybe do something like here, I could say, okay, well, I'm going to create one of these workers and I want it to just keep doing whatever it's doing forever. And then I want to fork one of these and we'll kind of maybe make a note to come back and think about like, do we want to fork as a daemon? Do we want to fork it in the scope? But maybe right now we'll fork it just to kind of get ourselves going. And then maybe we're going to want to do that a certain number of times. Maybe eventually we'll want to make this a parameter somehow, like maybe this should be either part of the web crawler config, or maybe it could be an argument here. But I think right now I'll just start with it just being a certain number. So we're going to have these workers, we're going to fork them off. And then I think one thing that we probably see here is these workers are all supposed to take from the queue. But at least if we don't do anything else here, there's going to be nothing in the queue for them to take from because we just put it up here. So I think one thing maybe we want to do here is we could offer all of the initial seeds. Yeah, and maybe we call that something like default parallelism or something.
Yeah, that was magic number was
More fun, definitely more fun. Okay, so now we're going to create the queue, we're going to create the ref, we're going to offer the initial seeds to the queue, and then we're going to fork off. Well, I guess maybe here I should make this like 8, and I should make it like default parallelism -1. But we're going to fork off these 8 workers who are just forever going to do this thing. And so I think conceptually that, I mean, if the we've again kind of pushed back to throwing what the workers are actually going to do, but I think if the workers do the right thing, I think this is basically going to do the right thing. Again, I think here maybe if we're just like flagging things to come back to, we need to think a little bit about like this like fiber lifetime. We want to make sure we don't interrupt these fibers ourselves before the user is done. And we also want to make sure that when the user is done, we interrupt these fibers. So maybe we'll come back to that in a minute, but we'll just right now just flag those as like things for us to think about.
Mm-hmm. And would you say those questions are prompted by the use of fork? Because I think, yeah, sometimes it can be useful to try to identify, you know, you probably are just good at getting that sense. Like once we've seen enough patterns, once you become an expert at something, you just know the problems you need to deal with. But as someone's learning this stuff, like what would clue them in that they might need to have these concerns? What was your, what did you smell in the air that prompted you to ask that?
Well, so I think one good clue for yourself is whenever you're forking fibers and you're not joining them again, you want to think about fiber lifetimes. And so here, we don't really want to join these fibers again, because if we join them here, then this is just never going to return, which, I mean, maybe is something we want to do. But at least if I'm doing this scenario where I'm forking and not joining, then I'm thinking about that.
Makes sense.
Okay, so let's think then about what this worker is going to do. And so again, like fork comprehensions are like nice to just say linearly, what are we going to do? And so I think the first thing here is for the worker to have anything, it's going to have to take one of these URLs from the queue. And so it's basically going to wait for another piece of work to be available. And when it's got it, it's going to grab that. And then I think then the first thing it's got to do with the URL is, the first thing that then this immediately tells us is right now this is not compiling because this is referencing a queue that this doesn't have access to. So that just says, okay, well, let's give it access to it. So we've got this queue of URLs, and then when we do the workers, we'll just give them the queue, and that will be happy, I think. Unless, let's see, yep. Okay, so we've got this URL, and then I think the next thing we need to do is we need to actually use the web service to get the HTML for it. So I think we could do something like HTML in web.get URL. Let's get URL. Okay, and now we're getting, so now this is a nice example of where the error type is helping us here. So we're getting an error message that this can fail with a throwable, but we said this couldn't fail at all. So right now I'm going to handle that by changing this to a throwable. But then that's going to make me deal with that. So now this is going to be a throwable. And I think another thing I'm going to want to think about is how do I want to handle errors here? Because we can imagine maybe when I call one of these URLs, it doesn't exist anymore, right? Like maybe I'm crawling New York Times and they've referenced something, but that thing, like whoever wrote that tweet that's so embarrassing has already deleted their tweet. And so this is going to fail. And I only have 8 fibers here that are doing all of my work. So I don't really want them to fail, because if they can, then eventually, one of my fibers is going to die, and then another one's going to die, and pretty soon I'm not going to have any fibers left, and my crawl is going to slow down to a trickle, and then it's just going to stop. So I think what I'm going to do is, at least right now, I'm just going to ignore these failures, because I'm just going to say, look, if it's a bad link, it's a bad link. I'm not crawling it, and I've got plenty of other things to crawl. If I wanted to, I could change that to log it or do something else, but right now, I'm just going to ignore it. Okay, so I've got this this new page, and since I've got the new page, I can then take advantage of this extract URLs thing to get all the links from the page. So I could do URLs and extract URLs, and actually this doesn't need to be an in, this can just be an equals, because this thing doesn't return a ZIO, it just returns a set. And let's see, did I just, I don't think I capitalized it. I was supposed to capitalize it. URLs. Okay, so now we've got these URLs. And now we've got to actually do something with this ref, which we haven't done before. And so we've kind of got to do 2 different things with the ref, if we think about it. So one thing is we need to put our new things we visited into the ref, and we need to update it with that. And then the second thing we need to do is we need to check all of the new things we've gotten against what's already in the ref and make sure we're not crawling something a second time. So I think this is another case where we could probably do it in line, but maybe making another little helper would be nice for us. So maybe I'll call this like modify crawl state. And this is going to have some URLs that are a set of URLs. And it's also going to have this ref, that's a ref of a crawl state. And maybe this is going to return back a new set of URLs to me, where this new set of URLs is, oh, I think it's actually going to need to return a ZIO because we're going to modify this ref. But it's going to return a ZIO with a new set of URLs. And this is going to be the ones that we actually want to crawl. So we will have removed, we'll have taken the original set, and we will have removed anything that was already in the crawl state that we've already visited. And so this is pretty easy. Whenever we've got a ref and we want to both update its state as well as return some value based on the state, the easiest operator for us to use is modify. And so we could do ref.modify, and this will give us access to the crawl state. And it'll let us return this tuple of the value we want to return and the updated crawl state. And so updating the crawl state, I think, is going to be pretty easy with that little helper method we created. So I think here we could just do crawl state dot visit all URLs. And I don't need to properly capitalize things. And then here, we just want to take this original set of URLs, and we basically want to diff it against the ones that are in here and only take the ones that weren't in here. And so we could just do URLs. And I think we can either use diff, or we could use, I think, the subtract thing, crawl state dot visited. And so I think that's like relatively nice now. Maybe we can just do that so it's on one line. And so now we could call this, maybe we'll call this like new URLs or something. And this is going to be modify crawl state with the ref and the URLs. And that's immediately going to push us to say, hold on, buddy, you're referencing a ref that is not here, but we can just pass it through.
Yay. Where does that go?
We'll secondary. Yeah, secondary, yeah. Yep, so just do that. Okay. So we've now got the new ones that we need to crawl. And so we're going to need to now offer all of those back to the queue, because that's now the new work that needs to get done. So we could do blank in queue dot offer all new URLs. And let's see. Oh, this should be a arrow, not an equals. There we go. Okay. So we've gotten our page here. We've extracted the links. We've updated our little ref with this. We've offered the new stuff. So we're just about ready to be done. I think we have one more thing we need to do here, which is we haven't used that process result function yet. So if we do this so far, like we're kind of going to be crawling, but our web crawler is going to be really boring because like we're not going to see any output from this. So we can maybe do this right here. We can say process result with the original URL and the HTML. And let's see. Right, so we need to pass that in here. So we'll just pass that in as well. And now maybe at this point, this is also getting to the point where it'd be nicer if it was on separate lines.
Mm-hmm.
And then we'll need to pass that there. Okay. And now I think this is basically going to do what we wanted to do here. Maybe initially I'm going to make this fork daemon. Just that's sometimes kind of a good starting point of like that'll make sure things don't get interrupted too early. Maybe they'll live too long, but at least they won't get interrupted too early. So we'll kind of make sure that we can do something with all this.
I don't think it knows, but we aren't using should crawl yet.
That's a very good point. So I think what we need to do then here is we've got these URLs. So basically, if we wanted to, we could do one more. We could say something like maybe call this URLs to crawl is equal to URLs.filter to crawl. And then, yeah, exactly. We can just put it there. And to satisfy our OCD, we can push this stuff over and we'll be good to go.
Nice. Cool.
Okay. And now let's take a look. It looks like we're getting some compilation. Yeah, exactly. Yeah, this is sometimes like the modularity is like super nice. Sometimes it means you kind of end up passing a bunch of stuff around, but I mean it's not really much of a problem.
One thing we could do, and sometimes when there is sort of like these two layers, one sort of setting up, queues and refs and workers, I think maybe with your initial approach of having the layer, one benefit is that we would have gotten
right. It was all up here,
argument.
And we could actually do that here if we wanted. If we could give ourselves a set of brackets around this, and we could define the worker here, and maybe that's actually a nice thing for us to illustrate. So if we wanted to, we could kind of give ourselves this. And then we could pull the worker and maybe the modified crawl state up into here.
Mm-hmm.
And then this doesn't need to be private. And this is one of those little things I think is a little bit like just whichever way you like it is fine. But I think you're right. That'll let us make these method signatures a little bit smaller.
Yeah, I think in this case, we'll still need to pass along the ref and the...
We'll do the ref and the queue, but we'll be able to get rid of the other stuff. Exactly.
And another pattern, I mean, there's so many ways that are basically equivalent. Another possibility would be to make another case class that took those as everything as arguments, essentially, and would do something like that. So we'll kind of get back to that initial case if this just had all the parameters. But at this point, maybe that'd be a little weird. But if it keeps getting more and more complicated and we need like 10 methods in here that all need access to that stuff, making a case class for like one of these workers essentially might simplify some of that.
Yeah. All right. So I think now we've got everything, at least theoretically, implemented. I think there's some possibility we just did something wrong with like the way we're stringifying or non-stringifying things where it's just going to blow up on us. But I think otherwise we're doing the right thing. So why don't we try running this? And kind of, I guess the cool thing is like, as with this iterative process, like when you have the last thing, you're literally ready to go. It's not like, oh, now I need to like kind of make the main method. So let's try this. Let's see. It looks like we're crawling some stuff.
Letterboxed, Wordle.
Every day I'm crawling.
Soup, vaccine, Russia, January, democracy, Herschel, coronavirus. That sounds like news.
So many things.
Cold water plunge, what's that? Amazing. Okay, cool.
Some kind of challenge. Yeah. So now I think our watch out here is I'm going to hit enter, and I'm going to bet that hitting enter is not going to do a whole lot for us.
Oh, we're crawling. Unplug your computer, Ed.
Yeah, exactly. So this is where we could probably improve here.
So this is that fiber lifetimes concern.
Yeah,
and they can be.
Yeah, well, yeah, it's kind of just like pushing us a little bit to think about what we want to do here. So let's play with this a little bit. And I think one thing we could potentially do is we could say, well, look, we're already, I think there are a couple of ways we could do it. One is we could kind of play with scopes, and we could do some things with scopes here. The other thing we could say is we're already forking this. So right now we're kind of allowing this to, we're kind of doing forking at two levels that I don't think we really need both levels, because here we are forking these things, and then we're just immediately returning this. So this method is going to return immediately, even though these things are going to go on forever. And then we're forking a second time in our main method. So I think, again, there are a couple of ways we can do it, but I think maybe one is we can actually be okay with this kind of not returning because we're forking it in the main method. And so maybe we can just make this something like ZIO dot for each par discard. And then if I wanted to, I could do something like chunk.fill. And I think here I can actually do collect the parts.
It's going to bring you into a new line there. Hey.
Oh, sorry.
Then two closes. We need one for that too. Cool.
Let's get some compilation going here to check ourselves here. So now this thing is actually never going to complete. It's never going to return because these workers are going to, well, we were missing a forever here. Somehow I deleted that when I shouldn't have. So now these workers are never going to complete because they're just running forever. And actually, at least if my VS Code was working, this would have a return type of nothing and would show us that. So this is never going to return. We're never going to hit this line here. But that can be okay where we're forking it here and we're interrupting this fiber here, and then it should interrupt its children. So let's, and a way this is maybe nicer if we're using like slightly higher level tools here. So let's try this and let's see how this works for us. Okay, so I'm doing lots of crawling, and let's hit exit. Well, that was nicer.
Yay.
Yeah. And so that's great. So we're both using some higher level tools, and we're also, yeah, getting kind of a nicer result there of, we saw that thing was kind of running as long as we wanted it to. And then as soon as we were ready, we could just shut it down there. So yeah, I guess this is one of our kind of usual things of like, we thought this would be a short thing and we're already over an hour. So maybe this is a good time to check in for questions, and I guess we can decide if we want to. I know we had some ideas for how we could make this fancier, but if we want to do that now, or I mean, we could either just put that on the side, or we could say we'll do that in a follow-up. But yeah, where should we go from here?
Yeah, I think most of the questions have been answered. Of course, let me know if I forgot about. Oh, I think something's tingling in the back of my head. What I think, Naveed, you had a question at some point, and I said I'd ask about. Like, yes, streams. Thank you. Yeah, stream.
Yeah.
It seems there was a streamy flavor to it. Queues, workers, repetition. Is there a streaming variant to this that we could explore? Maybe not today.
So,
maybe not sure. General, like what would the difference be?
So I think there is. I think one of the little bit of a challenges here is this desire for us to both do things in parallel with this parallelism and do things with this like exact number of fibers. And I think that pushes us a little bit towards something like this, at least in our underlying implementation. But what we could do is expose it as a stream. And so let me hit on both those points. So the reason I say that, like, I think it may be a little bit challenging to get exactly the control we want over the parallelism with just a stream and kind of a stream first is how the most natural thing we would do with a stream is you could think about this as like an unfold of a stream. You could say these seeds are an initial state, and from that initial state, we unfold the next set, and we unfold the next set, and we unfold the next set. And that's totally logical. But I think at least the kind of most naive ways we would do it, we would either end up doing a just kind of a sequential crawl, right? Of like, okay, we've like got this seed, we'll crawl this, that'll be the next thing we'll put on the stream, and we'll kind of take that from the stream and so on. Or we're going to have a little bit of the issue that kind of led us away from just using for each par without a queue of that we kind of can end up with more parallelism than we want to. We'll do like a map ZIO par 8, and then recursively we'll do a map ZIO pars 8 there, and we'll end up with a lot more than 8 for our parallelism. So I think probably we, under the hood, we want something like this. But I think one thing that we could definitely do is we could expose these results as a stream. And so maybe one really simple way we could think about doing this is this process result is able to do this UIO of any here. So this process result could just write to another queue that we construct a stream from. And then we could basically have a stream of these process results, and we could take as many as we wanted. So that could be a simple way that we could move this into a streaming world where we could end up with having a stream of URLs, and we can take however many we want to.
Yeah, but internally we'd still keep the queue and the workers.
I think so. I think we want something a little bit lower level like this that lets us kind of maintain this very tight control over the degree of parallelism, even though we're doing these multiple calls.
And I've seen, I mean, this is definitely, this pattern is definitely something to identify. I know that, Adam, you've used it a lot in different contexts, and when it's, you don't just want ZIO, you don't just want Z stream, you want something kind of in between worlds where you want to control this parallelism. And it really, making this little worker function, pulling off a queue, calling forever, that works in a lot of different contexts. So definitely add this to your toolkit. This works in a lot of different places, not just web crawlers. What about, do you think maybe there's some, because we've seen it a lot of times, do you think there is some latent abstraction? Would there be a neat way of turning this into some weird half stream, half abomination abstraction?
Yeah, so maybe I can dust it off and I can post something for it after this. But I think at least in some places you can call it kind of like a shard operator, and so you just you can think about basically giving it some. I think this one has a little bit of complexities with the fact that we want the workers to offer values back to the queue, which I think is maybe a little bit not the usual thing. I would say the most common thing is kind of there's a producer that puts work into the queue and just all the workers take work from the queue. And so you could think of having a shard operator that basically just creates a bunch of workers and has them all take from some source. And you provide a function that kind of defines what the worker does. I think this maybe gets a little bit more complicated here, but yeah, I mean, I think you could have I don't know what you call it, maybe a shard recursive version where that function for the workers gets access to a reference for the queue. So I think that could be a fun thing that we could explore a little bit, either offline or in a follow-up session. Yeah, that'd be cool.
Yeah, and those sometimes when you make something abstract, basically you probably just have this method where you'd pass in basically the same amount of code just as arguments to a method because you need to parameterize it by all this stuff, and maybe you wouldn't gain anything from it. But it sounds like it'll be fun to explore. Maybe
yeah, well, and I think it's one of those things. I mean, sometimes just even doing the fold or doing the unfold, even if you don't end up using that method because you just use the sum or the filter or whatever the specific thing is, it kind of it forces you to abstract a little bit and think about what the commonality or the differences are of I mean, even just that initial conversation got us thinking about are the workers just taking from the queue or are they actually offering back to the queue? Because those are two different things.
Yeah, interesting to change all these things to A's and B's and see what we're forced to.
Exactly.
Let's save that for the future. That sounds like a fun experiment. Though if anyone else wants to try that, I'm sure this code will be shared eventually and posted in the Discord, and give it a shot yourself. Race to it.
All right. Awesome.
Well, thank you, Adam. Thank you, everyone.
Thanks so much, everyone.
See you next Friday.
All right.
Oh, wait, real quick. Actually, maybe we should warn about the hackathon coming.
Oh yeah, that is a great point. Yeah, we've actually got several things coming, so we may be doing a little bit of rescheduling. But yeah, we've got it's crazy how quickly stuff is coming up. I think it's not. I think next week we're okay. If I'm recalling correctly, yeah, I think next week we're okay. The following week, it's the 26th through the 28th is going to be the ZIO hackathon. So if you're anywhere around the New York area or interested in going there, you should come and check it out and get your ticket. And if not, there's going to be lots of remote stuff as well. So you should come from your living room. And then the following week is I'm going to be giving a talk, I think on Friday at Scale IO in France. So if you're in France or around France, then you can come to that. And then I think the following week, the 11th, I think we're going to have Pierre as our special guest to talk about shard cake. So we've got lots of cool stuff coming. And then the beginning of December, we've got functional Scala in London. So it's a really packed back half of the year. We're going to kind of get in all of our goodness, and then we'll be able to settle down for Christmas and Hanukkah holidays and all that stuff. But yeah, lots of good stuff coming.
Amazing. My screen's so bright. Okay, cool. Well, all right. See you at all those things, everybody.
Yeah. All right. Take care.
And
bye.
Everybody.